In today's ThinkScript tutorial, we're going to be building our very own volume indicator. Through this indicator, you'll get a chance to see not only what today's volume is, but also how that compares to, say, the past 30 days average, along with the past 90 days average. Let's say instead of 30 and 90, you wanted a whole different set of numbers here. You can simply come inside of the indicator's study settings menu, change the numbers here. Let's say instead of 30 and 90, we want to try 180 and 360. If I click OK, you'll see that not only do these labels change, but so does the actual volume inside of it. So the indicator we'll be building is dynamic, and I'll show you how to add in this functionality. Another piece of functionality that we'll also be adding in, which is my favorite, is the ability to go from this long number format where you see the volume in millions along with the decimals, and we can trim that down to something that I think is a little bit easier to read. That's the short number format, and this is also a piece of functionality we'll be building in our indicator. So if we take a look at Tesla, for example, we can see Tesla's volume today is 191 million shares traded. The 180-day average is just 115, so we're greater than, today's volume is greater than the 180-day average. That's why this label is green, and we can also see by how much greater is today's volume. Same thing for the second label here as well, 360 days. Now what happens if we say come into something like Microsoft? Microsoft, we can see both labels here are gray because today's volume average is either equal to or less than the 180-day average along with the 360-day average. So these labels will be smart, and I think the clean visual representation here will make it really easy for those of you that like to use volume to monitor trends to be able to see where there's price action that's standing out. Now, even if you're new to ThinkScripting, to coding, it doesn't matter. I'll walk through each concept step by step, and in this tutorial, you'll know how to build this indicator from scratch, along with incorporate all of these different functionalities that we just talked about. This is a beginner-friendly tutorial, so don't be scared. We'll go through each of these concepts step by step, and by the end of the tutorial, you'll have learned how to build this indicator. Now you can also download the final version for free from our website, and I'll leave a link to that in the description box below. For those of you that are curious around how this is built, let's go ahead and get started with writing some code. I'll start by removing this indicator from my charts, and we can get started with a clean indicator. Now to get started, the first thing we can do is click Create, which will allow us to now write some code. I'll start by giving this a name. I'll call this ti_vol average labels. And inside of this code, we can delete everything we see inside. Now, if you think about this, the most important component of this entire indicator is the volume. We need to find a way to bring in the volume that we see down here and have that referenceable inside of our code where we can tweak it, perform some calculations, etc. So to do that, I'll write def vol, and there simply write volume. Volume is one of those variables that ThinkOrSwim makes available to you, similar to the closing price of a candle, the last price, the opening price, etc. So there's nothing more that we need to do here. Now, if we say output the value that we see here, I can use the add label function. I'll leave a link to a tutorial which dives into this function in a little bit more detail, and you'll learn more in this tutorial as well. But here, for the time being, just follow along. We'll say yes, volume is what we'd like to see inside of this label, and I'll give this label a color of yellow. This is simply to test, that's all we're doing here when we write this code, to see what is this volume value that we're getting. So if I click OK, and we click Apply, you'll see nothing on our chart. The reason that is, this volume average indicator that we just created got placed inside of the volume subpanel, which I've hidden on my chart so we don't see any indicator. Now if I move this manually up to say our price panel, I click Apply, then we can see the label plotting in our left-hand corner. Now this is giving us the volume on the current time frame we're on. We can see that right down here, the most recent volume, 28,339, and that's what we see inside of our label as well. However, when I say move this down to something like a 1 minute, this label changes. That's because this is now getting the 1 minute time frame chart's volume, and that's not what we want. We want to tie this to the daily time frame chart, and we want this label to stay the same regardless of whichever time frame we're on. So to do that, we'll come back inside of our code here, and we'll add in one parameter that volume can take, and that's going to be which period do we use. So here I'll say period is equal to day. If I click apply now, apply, and we test this one more time. Now if I go from the daily time frame to a 1 minute time frame, we still see the same number inside of our label. So now we're holding the volume from the daily time frame across different time frames as well. Now if we come back inside of our code, the next thing we need to do is add in some code which tells ThinkOrSwim that, hey, we want to see this indicator always plot on this price subpanel, which is where we see our charts, the candles, etc. We don't want it to go on the lower subpanel. We don't want it to be on that volume subpanel. We want it to be on the upper charts inside of ThinkOrSwim. So there we can say declare upper, and now ThinkOrSwim will know that, hey, this indicator only works on the upper panel of the charts inside of ThinkOrSwim. So now, if I click apply, this is what we have as of right now. We've declared the indicator so that ThinkOrSwim knows this always applies up here, so we see our labels on our chart, and we've referenced the daily time frame volume. Now we can move on to trying to get the average of the daily time frame volume. So let's go ahead and do that. I'll add in one more variable here called average, and we can use the average function. This is a function built inside of ThinkOrSwim, and we give it the parameter volume, and we can specify for how many days would we like to see this average. So I have down here the volume average indicator where it's tied to the number 50, which we can use to test. So I'll feed in the value 50 here for the time being as we're still in our testing phase. I'll take this average, plot that out in our label, which we can use to test, click apply, and we can see here the average is 30,838,894, and that lines up with the average value that we see built inside of ThinkOrSwim. So now what we know is we've appropriately gathered the volume, and we're referencing that, and we're also appropriately referencing the average, and that lines up with what ThinkOrSwim is showing us. Now, one downside to hard coding values like this 50 is anytime, say, you want to change this, maybe instead of 50-day average, you want to see the 30-day average. Inside of this volume average indicator, it's pretty easy. We double click the indicator and we can change the length here, and that will automatically update down here. Inside of our indicator, we need to click the code, we need to come inside of this average, we need to then change this 30. That's not ideal, and that's not what we're looking for. So this is where we can use in a concept called the input variable. If I select input length 1, and there, let's give this a default value of 30. Now I can tie this length 1 as the variable inside of our average as the length that's used. So now if I click apply, we're using the 30-day average. You can see these labels still line up. But say I clicked OK, you were using this indicator and you wanted to change this value, simply double click, and now we can change that value instead of needing to go inside of the code, and it will update the labels for us. So I think that's pretty neat, and it's a smart way to write the code so you have as few hard-coded values inside of here as possible. Now we said we wanted two different averages. We wanted to compare this over, say, a 30-day and a 90-day, or whatever two lengths you might choose. So this part should be pretty straightforward for you now. We create one more variable. We'll give this length 2, set this equal to another number, and we create one more average variable here, and we set that equal to length 2, and we need to also change the name of the average from just average to, say, average 2. We'll also add in a 1 up here for the average 1, just so it's a little easier to read and follow along with. So now if I click apply, our code compiles as we would expect. Now, once we have our volume and our average, we have the two components necessary to also be able to reference this from that percentage format. And that's quite simple. It's literally the volume over the average, and that will then give us a percentage of how does today's volume compare to the average volume we've seen. If the numerator up here is greater than the denominator, then we'll see a percentage that's greater than 100%. If it's less than, we'll see a number that's less than 100%. So let's go ahead and write out that calculation here. I'll say %1 is going to be equal to volume divided by average 1. Pretty simple there. Same thing for average 2. %2 is equal to volume divided by average 2. So now if we output what we see here, I'll say %1 inside of our volume, see how this label changes. I'll click apply, and now we can see that today's volume in Microsoft is 93.8% of the 30-day average volume that we're used to seeing. Now 0.9383, that's not super readable. So to be able to change that, we use the as percent function, and again, another built-in function inside of ThinkOrSwim, and we can feed in %1 as the parameter for the as percent. If I click apply now, you'll see that this number changes into something that's a little bit more readable, 93.83%. So now that we have the as percent under our belt, we've calculated the averages, we've turned those averages into also percentage form, and we've referenced the daily volume, we have enough to start writing the first set of labels here. So let's go ahead and do that. The first label we had was the actual volume. We want to see today's volume outputted. So we can say add label. Yes, that's the first parameter, is when would you like to see this label? So we say yes, since we'd always like to see this label. Now, the second parameter here is going to be what would you like to see inside of the label? So there I'll say volume and plus, and this allows us to concatenate the actual volume here as well to the end of this. And I'll give this a color. I'll give mine light gray and close this out with a semicolon. Now, if I click apply, we can see volume. We see today's volume outputted there pretty nicely. Let's repeat this for the bottom two as well, for our two different sets of averages. So I'll copy paste this one more time. Now, inside of this label, we'd like to see, say, 30-day average. And here, this is going to be average 1. And we'd like to see this outputted, again, with, say, color.gray for the time being, or light gray, excuse me. We need to repeat this one more time for the second set, which is the 90-day average. And I'll add in average 2 here, and we have light gray. Now I can delete this last line of code for the time being. We're going to incorporate this as percentage as part of these labels, so we don't need a fourth label. And if I backspace out of here and we click apply, on our charts now we have today's volume, we have the 30-day average volume, and we have the 90-day average volume. Now in this case, we can see that both of these values are the same, the 30-day average and the 90-day average. That doesn't really make sense to us. That shouldn't be the case, so let's see what might be happening there. If I click OK and we apply, we can see that our two different inputs here have the same lengths. So if I were to change this back to the 30 and we now click OK, apply, we can see that these numbers are the way we would expect now. We have today's volume, we have the 30-day average, and we have the 90-day average. Now let's come back inside of our code. There's a few different things we need to still tweak here. The first is we need to add in this percentage value that so far we haven't displayed anywhere. It's really hard to know that, hey, today's volume compared to the 30-day average, how much of that is it? What is the percentage form here? Let's make that a little easier to read. So to do that, we come back into our 30-day average label. We can add in one more plus. And now we add in a divider. So I'll add in a space first, then a vertical divider, and then I close that out after adding one more space. And then we can say plus, and now we add in our as percent, and then we fill in %1 here. And if we click apply, let's see what we get. We get the 30-day average along with the actual percentage form here outputted. Now we repeat the same thing for average 2 down here. So I'll say plus, again, open the quotes, add in the divider along with the space so it's nice and clean. We can say as percent, and this time feed in %2. Now if I click OK and apply, we can now see the percentage outputting to the right of the divider. Now, one thing that still is not fixed with this code is if, let's say, we changed our labels from 30 and 90 day to something like that 180 and 360 day example that we were looking at. If I click OK and apply, you'll see the numbers changed here across the board, but the actual value for our label did not change. That still is hard-coded to 30 and 90 days. So let's go ahead and fix that. I'll come inside of our code here. And where we have the 30 spelled out, we can delete that. Same thing with the 90. And we can add in one more variable, which is the actual length from the input. So we can say length1 plus daily average, and then for our second variable, we'll say length2 plus the d-average text that we have. Now if I click apply, you'll see that we can pull in the integer first, and then it continues to write out the text that we had, then it pulls in another variable, and then it pulls in some more text that we've added, along with then the percentage value. So now this is getting to be a little bit smarter. It's starting to become a little bit more dynamic. We need to still add in one more piece of functionality here though, which allows these labels to change colors based off of what the volume is today compared to what it's been historically over whichever averages you've chosen. For example, if I came back to SPY here, we can see that we see 228% here and 210%, but these labels are still light gray. That makes it a little harder. That's a little bit more work that we have to do to analyze it. Oh, this is greater than, say, the average volume. It should be a little easier on our brains to do that, and we can use colors for that. So let's change this color.lightgray, and instead of having just a color.lightgray, we can add in a little Boolean condition here. We can say if our %1 is less than or equal to 1, and the reason we're saying 1 here instead of 100 is because %1, remember, is outputted as a value between 0 and 1, with 1 being 100%. So we're saying if we're less than or equal to 100% for our volume change, then we want the color.light gray, else we'd like to see color. Let's just keep this as green instead of light green. We repeat the same thing for our second set of labels here as well. We'll say if %2 is less than or equal to 1, then color.lightgray, else color.green. Now if I click apply, we can see that our labels are now changing colors as well. Let's test this out by going back to that chart of Microsoft, and these labels should go back to being gray, which they are. Perfect. So as of right now, what we've done is a majority of the code we would need. We've defined today's volume, we've defined the averages across two different lengths, which the user can select themselves. We've then translated each of those averages to a percentage, which I think is a little easier to comprehend using our just eyes very quickly. We can see 99.76, 93.49%. Now the last thing that we want to change is this number format. I'm not a huge fan of seeing all of this out in the millions here, along with down to the decimal places. Now, I know not everyone wants to see this format, so we want to make this something the user can control. So as soon as we say the user can control this, automatically your brain should be thinking, oh, that's going to be an input variable. So we can say input. I'll give this a name of num format. And here we can use a bracket and say the default format is going to be the short form, which we'll define. And alternatively, the user can also select the long form, which will be exactly what we see on our charts. Now that we've defined this, we need to actually add in the functionality that powers this line of code. To do that, we use something called a switch function. We say switch, we feed in this input variable that we just gave it, and now we have to write out the two different cases, is what they're called, short and long, and write in the logic for each of those cases. So I open the bracket there, I'll say case 1 is short, case 2 is long, and we close out this little bracket here. Now this code will go back to compiling, but we don't really still have the functionality inside of this that says, hey, what is the short form? What is the long form? So we need to define that. Now, if you think about this, there's a few different components that are going to be using the short form and the long form. We can see here today's volume has a number, so that's going to be either short or long. We can see length, or average 1 rather, has a volume, but not the percentage here. That doesn't really need to be short or long form. So it's just the volume that we care about here, the average volume. And same thing with length 2. So there's 3 different variables here that we would like to change based off of what the user selects here. So let's go ahead and define each one of those variables. We have vol, and that's going to be vol plot. I'm adding plot there just because these variables can't all be the same name. Average 1 plot, and def average 2 plot. Now that we've defined each of these variables, you can see we're getting an error down here which says that, hey, there's no value that's ever been assigned to any of these variables. So let's go ahead and fix that. For our short form here, we can say vol plot is going to be equal to whatever the volume format we had, and that's going to be, say, divided by 1 million. That should be simple enough, right? So if we click 1 million here, and we add in this vol plot to our case long as well, that should give us the code that allows us to compile. We need to repeat this for the two other variables as well. So I'll say average plot1 is equal to average 1 divided by 1 million. I think I'm missing a 0 there. And then we copy paste this one more time down here just to see if this compiles, and then we'll fix this code. And then we repeat this for average 2 plot, and we can say average 2 is divided by 1 million here as well. And then I'll copy paste that down here. And that should allow this code to now compile. Now, what we've noticed is this code is compiling, but inside of our long format, we've still divided this by 1 million. That's not what we want here. If the user had selected long, we simply just want to see the same volume that we had outputted above. Same thing with the average, everything down to the decimals. So I'll delete the divisor of this million here, along with down here as well. And now we need to actually plug in these variables. Every time down here we've said volume average 1 or average 2. We're not really looking to now output that. We've taken these values. If the user is selected short, then we're going to divide that by 1 million. But if the user is selected long, we'll still pass through the same variables. So instead of vol here, I'll say vol plot. And instead of average 1, we can say average 1 plot. And instead of average 2, we can say average 2 plot. Now if I click apply, OK, we can see that the user can select short and these numbers trim down. We still have decimals at the end, which we'll fix. But now if we say go from short to long, apply, we can now see this in the millions. If I go back to short, we can see this trimmed down in a nicer format. Now let's make this a little easier to read by rounding and getting rid of these decimals that we see. So I'll come back to our vol plot. And here we can wrap all of this division inside of one round function, which the first value is what are we trying to round, and the second, after the comma, is to how many decimal places. So there I'm saying 0 since I don't want to see a single decimal here. So I'll say round 0, and then we add that in one more time, round and 0. Now if I click apply, we can see that these labels cleaned up much nicer. And that's it. We have our finished product here. If I click OK, apply, and we try testing this indicator on a few different charts, let's go to SPY here. SPY, we can see today's volume, 189 million. We can see the 180-day average here. We can see the 360-day average. The numbers are nice, easy to read. We can see 180-day average is 83 million, 360-day average, 90 million. So we're greater than both with today's volume. We can see that with terms of percentages as well, 228% for our 180-day average, 210% for our 360-day average. If we change this number here from, say, 180 to maybe we're just looking to compare short term, maybe 5 to 10 days. I click OK. We can see our labels automatically update, not only the text here, but also the actual calculations inside of the code. And that makes this much easier to be able to monitor volume across however many different lengths you'd like. Now let's say you wanted to add in one additional length. All you would need to do is add in one additional input length variable, define that out using the average and the percentage, feed in one more plot variable and add that to each respective condition, the long or the short case, along with the long case. And then you can create another label just by copy pasting this and replacing everywhere where you see 2 with 3 since that's going to be your third length. Pretty simple, pretty easy to do, but I think you should be able to see just how powerful these 29 lines of code can be for your trading. Again, you can download the final version of this indicator from our website for free, TOSindicators.com, and I'll leave a link to the exact download in the description box below. I hope you found today's tutorial useful in building a very simple volume indicator which allows you to track not only today's volume, but get a little bit more context by comparing it to the past, say, 30, 90 days. In this case, I have 5, 10. You can choose whatever you'd like. Take care, everyone. I hope you found this tutorial useful. Even for those of you that were beginners, you made it through, so give yourselves a pat on the back. Hopefully you learned a little bit more about ThinkScripting here, gave you a little bit more confidence to try and tweak this some more, and dive deeper into ThinkScripting. Be sure to check out more tutorials on our website if you'd like. That's TOSindicators.com. And there, if you come into our indicators page, you can find many more tutorials just like this one, which will allow you to practice your ThinkScript skills and get better at them. All right, take care, everyone. Good luck trading, and I'll see you in the next update.